Ever wonder how your phone or a robot can run complex AI tasks like real-time translation or object detection without draining your battery? It's not magic. It's a breakthrough called Intra-DP, and today we're diving into how it's redefining mobile AI. Let's break it down. Here's the challenge. Mobile devices are powerful, but they're not supercomputers. Running heavy AI models like facial recognition or self-driving algorithms is like trying to cook a gourmet meal with a single pan. It's slow, energy-intensive, and inefficient. Traditional methods offload work to the cloud, but that's like sending ingredients to a restaurant every time you want to cook. It's slow, it's power-hungry, and it creates bottlenecks. The secret: local operators, parts of an AI model that don't need the full picture to work. For example, a convolution operation in image recognition processes small image patches independently. By breaking these operations into smaller pieces, Intra-DP ensures your device is always computing, even as data streams to the server. It's like having a team of workers. One handles the oven, another chops, and another assembles. No waiting, no delays. But Intra-DP isn't the only game in town. Researchers are pushing AI further with systems like CoEdge, which lets heterogeneous devices, smartphones, drones, sensors, collaborate. Imagine a drone scanning a forest for wildfires. It could offload complex analysis to a nearby server while using its own sensors for real-time tracking. This dynamic task partitioning adapts to each device's capabilities, like a team of workers with specialized roles. Other innovations include CoActo, which enables concurrent execution across devices, and knowledge distillation, a technique that shrinks massive models into lightweight versions without losing accuracy. Meanwhile, attention mechanisms, like FlashAttention and sigmoid self-attention, let AI focus on critical data, improving efficiency. These advancements are making AI not just faster, but smarter and more adaptable. So why does this matter? As AI becomes embedded in our daily lives, systems like Intra-DP and CoEdge are the unsung heroes ensuring our devices stay efficient, responsive, and future-ready. It's not just about speed, it's about making AI work seamlessly in the real world. Thanks for watching. If you want to see how these innovations power the robots in our experiments, hit subscribe. Next time we'll explore how AI is making robots smarter, not just faster. Stay curious. Ever wondered how your phone or smart home devices recognize your voice, detect objects in photos, or even drive itself, without needing a supercomputer? The answer lies in deep neural networks, DNNs, the brainy software behind AI. But here's the catch. Running these complex models on small, power-hungry devices like smartphones or drones is a huge challenge. Today, we're diving into cutting-edge research that's making AI faster, smarter, and more efficient, especially when multiple devices work together. Let's start with a key problem: edge computing. Imagine a drone scanning a forest for wildfires, or a self-driving car processing real-time traffic. These devices have limited battery life and processing power. Traditional DNNs are like giant, energy-guzzling machines, too heavy for small devices. But what if we could split the work? That's where CoEdge comes in. CoEdge, developed by Zheng and colleagues, is a system that lets heterogeneous edge devices, like smartphones, drones, and sensors, collaborate to run AI models. Instead of one device doing all the work, CoEdge dynamically partitions tasks based on each device's capabilities. Think of it like a team of workers. A strong, fast worker handles complex tasks, while others take on simpler ones. This adaptive approach saves energy and speeds up processing, making AI feasible for real-world applications. But CoEdge isn't the only game in town. Researchers are exploring other tricks to make DNNs work better on edge devices. For example, CoActo, 2024, takes collaboration further by allowing devices to execute tasks concurrently, like a relay race where each runner passes the baton seamlessly. Meanwhile, techniques like large-margin softmax loss, 2016, and knowledge distillation, 2021, help shrink massive models into lighter versions without losing accuracy. Think of it as trimming a bulky coat to fit a smaller frame. Another big leap: attention mechanisms. Papers like sigmoid self-attention, 2024, and FlashAttention, 2022, are refining how DNNs focus on the most important data, like a detective zeroing in on critical clues. And for those times when data is spotty, like in a moving car, researchers are building more reliable communication frameworks, ensuring AI keeps working even when signals drop. The broader picture: these advancements are paving the way for smarter cities, autonomous vehicles, and real-time health monitoring. By making AI efficient and collaborative, we're not just improving technology, we're making it accessible. So next time you use a voice assistant or see a robot in action, remember, it's the result of decades of research, from foundational architectures like RaisNet and DenseNet to modern innovations like CoEdge. The future of AI is collaborative, adaptive, and everywhere.